We're going to start chapter 4 with section 4.3, right triangle trig. And we're going to split this section into two parts. We're going to first take a look at how to evaluate some of our basic trig functions of acute angles. Now some of this is familiar and some of this is new. So this is going to be part 1, and then there will be another video explaining how to use the fundamental trig identities. So we're going to use the lengths of 3 sides that form 6 ratios that define the 6 trig functions of any acute angle. That's important. It has to be an acute angle. Now, we've already seen cosine, sine, and tangent in a previous course, probably geometry. But there are 3 new trig functions: cosecant, secant, and cotangent. But just like sine, cosine, and tangent, they also have a special relationship with this triangle. And these are all of the ratios that these 6 trig functions have. Now, sine, cosine, tangent, we probably have memorized so, ca, toa to help us keep these ratios intact. The first one, so, the S stands for sine. The O and the H stands for opposite over hypotenuse. Ca, the C stands for cosine, and then it's adjacent over hypotenuse. Toa, the T stands for tangent, and the O stands for opposite over adjacent. Now, the other 3 trig functions are actually reciprocals of these original 3 that we've already learned. Okay, so the first one, cosecant, is actually the reciprocal of sine. If you notice, sine is opposite over hypotenuse, and cosecant is hypotenuse over opposite. And then secant is the reciprocal of cosine, so secant is hypotenuse over adjacent. And then the last one, cotangent, is the reciprocal of tangent, and that's adjacent over hypotenuse. So in example 1, we're going to use this triangle to find the values of the 6 trig functions. So we're just going to write out the 6 ratios. Well, first off, we have to find the length of the hypotenuse. Hopefully we all have this memorized, that this is a 3, 4, 5 Pythagorean triple. And we're going to base it off of the angle on the lower left-hand side. So, sine of that angle equals opposite over hypotenuse. Cosine of that angle equals the adjacent side over hypotenuse. And tangent of that angle equals opposite over adjacent. Now for the other 3, I have cosecant equals hypotenuse over opposite, or the reciprocal of sine. Secant equals hypotenuse over adjacent, or the reciprocal of cosine. And cotangent equals adjacent over opposite, which is the reciprocal of tangent. Example 2, find the values of sine of 45, cosine of 45 degrees, and tangent of 45. Hint, draw a triangle. So what I first might draw is draw my right triangle and put in a 45 degrees. Now, it does not matter where you decide to put your 45, because we know that the other angle has to be 45, because every triangle adds up to 180 degrees. Now, why don't we deal with the most basic 45, 45, 90 triangle relationship? So that means each of the legs are 1. Remember, the legs always have to be the same unit, which would make the hypotenuse be the square root of 2. Now that could be found by either doing the Pythagorean triple or Pythagorean theorem, or by remembering the relationship between a 45-45 and a 90 triangle. So now the sine of 45 degrees, now it does not matter which 45 degrees you're looking at, I get opposite over hypotenuse. Now remember, we cannot leave a radical in the denominator, so I have to rationalize it. So I end up with the square root of 2 over 2. Cosine of 45 is adjacent over hypotenuse. And again, we have to rationalize that the same way. So I end up with the square root of 2 over 2. And then tangent of 45 equals opposite over adjacent. So that just simplifies to 1. Use this equilateral triangle to find the values of sine of 60, cosine of 60, sine of 30, and cosine of 30. Okay. Now I'm going to use the triangle on the right-hand side and go from there. So the sine of 60 is equal to opposite over hypotenuse. Cosine of 60 is equal to adjacent over hypotenuse. Sine of 30 is equal to opposite, so that's 1 over 2, and cosine of 30 is adjacent, which is square root of 3 over 2. Now, hopefully you're noticing that the sine of 60 and the cosine of 30 are congruent, and the cosine of 60 and the sine of 30 are congruent. Every triangle has this relationship, okay? Because again, this is the most basic relationship between a 30, 60, 90 triangle that we can have. And any triangle that's a 30, 60, 90 will be some multiples of these numbers. Now, this chart, this slide must be memorized. Okay, first off, so right off the bat, this must be memorized. It must be memorized that we know that the sine of 30 is equal to the sine of pi over 6, okay, which is equal to a half. Now, we've already solved that in the previous slide. We also found that the cosine of 30 is equal to the square root of 3 over 2, and we found the sine of 60 and the cosine of 60. We also found the sine of 45, cosine of 45, and tan of 45. Okay, all of this must be memorized. You must know the degrees as well as the radians, as well as what it all equals. Okay. And this is where part 1 of this video will conclude.